Hey everybody, my name is Tommy, and I'm going to tell you today how to kill a polyarc. This is one of the most common questions I receive, so I figured I'd put a short video together. I would say the most common way people end up killing polyarcs is exposing it to a lot of silicon siloxanes. This generally comes from excessive column bleed from a PDMS type column at high temperatures, but it can also come from residual reactants from a derivatization process or high concentration analytes that contain silicon. Around 1000 ppm or above is what we would consider to be a high concentration in this case. So advice to decrease these effects would be to limit upper oven temperatures when using a PDMS column. Don't push it above what they would recommend for the normal operation temperatures. And the way this would normally show up is in peak tailing, because these siloxanes will bind to our catalyst and create active sites for certain compounds. You can see on the figure on the right what a peak would look like without the tailing and with the tailing as it starts to interfere with the critical pair. So if you encounter this, there really isn't a way to undo it, but it's a gradual process that over time usually contributes to most of the replacement reactors over the 6 month to 1 year period. Sulfur is the main compound that can actually kill the polyarc, the only compound that can kill the polyarc. So what happens here is after about 0.6 milligrams, all of your responses across the board will decrease essentially to zero after a few injections. So this is a cumulative effect. The polyarc can handle a lot more sulfur than a typical methanizer would be able to, or a similar reactor, but there is a limit to it. So what we say is try to avoid solvents or diluents that contain sulfur like DMSO or CS2, or concentrations that are higher than about 1000 ppm. If you're below that concentration, you can run thousands of injections. If you're looking at trace level sulfur, it's not a problem. But if you start to hit the polyarc with quite a bit of sulfur, then you're going to run into this issue where all responses go down. If that happens, give us a call and we can tell you the regeneration process. It's pretty simple, but it will just come at a reduced future capacity for sulfur, but at least it can keep you running for a few days until you get your replacement. The polyarc can also get damaged from exposure at high temperatures to the environment. And by this, I mean, if you have disconnected the polyarc while it's hot, or if you've turned off any of the flow rates of air, hydrogen, or the carrier gas while the polyarc is hot, you're going to run into some problems potentially that would usually show up in either peak tailing or irregular peak shapes. So the way to avoid this is to always make sure before you do any maintenance to cool the polyarc down, before you disconnect any fittings or turn off any gases. And if you're going to be down for an extended period of time, it's simpler usually just to cool the polyarc down, and that way you don't need to worry about somebody else screwing things up. One other point I want to make is with the electronic flow controller, if you're using our standalone device and you encounter frequent power outages in your laboratory, you may want to look into get an uninterruptible power supply to prevent this kind of damage to the polyarc. Last thing is the heater. So this isn't performance related, but the polyarc does contain a heater with an RTD to sense the temperature. If you do excessive cycling of the heater, meaning you cool it down and heat it up to maximum temperature frequently, as in maybe once a day, I would consider that frequent, then you may want to look into doing a controlled ramping in a GC method rather than going from 0 to 450 or 293, whichever your set point is, in one fell swoop. Usually what will happen here is if you damage the heater, it will give you a fault on whatever you're using for your heater, whether it be the thermal locks or the temperature control like the one picture on the right. So again, to reduce the likelihood of this happening, I would just say heat at a slow rate if you need to heat frequently, or keep the temperature at the set point with this gases flowing, of course, while you're not running. That's what we do in our labs. The polyarc is safe, just like an FID, to stay hot. That's what's best for the heater. So in summary, the compounds that can cause damage are sulfur and silicon. Sulfur will decrease responses across the board at high concentrations. Silicon, usually from column bleed on a PDMS column at high temperatures, will result in peak tailing. Exposure can cause damage, meaning lack of all three of the gases and all the connections. If you disconnect anything or turn off any gases with the polyarc hot, you could cause damage. And then the last thing is the heater itself. Try not to cycle it more than it needs to be cycled by either keeping it hot or doing controlled ramp if you need to heat frequently. So thanks for listening. If you got any questions, that's my email address. That's the ARC's main line. Go ahead and give us a call. We're willing to talk about whatever kind of questions or specific compounds you want to look at or situations. So have a good day.